Hello my dear students, welcome to my channel. I am your Sumam. Today we are starting fluid statics. In fluid statics, we are going to study the behavior of the fluid under rest. So let us consider the forces acting on the fluid in static conditions. There are two forces are acting, among which one is body force and other is surface force. So body force is due to some external influence like gravity. It is dependent on mass of the fluid. Surface force is either tangential force or normal force and are exerted by the fluid on the boundary by direct contact. So normal force is the pressure force. In fluid, the tangential force or shear force is the viscous force. So now the fluid is under rest. So that means there is no fluid motion or there is no relative motion between the fluid particles. That means there is no viscosity or there is no viscous force. So in fluid in static conditions, we have to consider the body force and the pressure force. Now comes to the intensity of the pressure. So intensity of the pressure or the pressure is the normal force which is exerted by the fluid on a unit area. So if the fluid is in static conditions, the force exerted by the fluid is perpendicular to the area. So let me explain this with an example. So let us consider a cylinder which contains some fluid. Consider a point on the bottom of the container. Now dA is the area which is enclosed by this fluid element. Now the force acting on this fluid element, that is equal to dF. So the intensity of the pressure at this point B equal to dF by dA. Normally the intensity of the pressure is represented by the lowercase letter p. So P equal to dF by dA. So what is the unit of P? The force, that is in Newton, and area is in meter square. So the unit of intensity of the pressure equal to Newton per meter square, or it is called Pascal. The most commonly used units of pressure is kilopascal. 1 kilopascal equal to 10 raised to 3 Pascal. Similarly, 1 megapascal equal to 10 raised to 6 Pascal. Other common units are bar. 1 bar equal to 10 raised to 5 Pascal. In gravitational system of unit, we are using 1 kilogram force per centimeter square is related to 9.807 Newton per centimeter square. If you are considering the total force that is acting on the total area, if capital A, that is the total area, then the total force that is acting equal to P into area. P is the intensity of pressure and A is the total area of the cylinder at the bottom. So in fluid mechanics, the pressure force is expressed by capital P. So this F is now replaced by capital P. So P equal to the total pressure force acting equal to small p into area. So P is the pressure force. Now let us discuss about Pascal's law. What is Pascal's law? Pascal's law states that the intensity of the pressure at a point in a fluid at rest condition is equal in all directions. That means if you are applying certain pressure at a point in the fluid under rest condition, it is equally transmitted in all directions. The unique property of fluid static pressure can be proved by considering the forces acting on a fluid element within the fluid under rest condition. So let us consider the equilibrium of an arbitrary fluid element in the form of a triangular prism within the fluid under rest conditions. So this is the triangular prism. So it has the dimensions dx in x direction and dy, that is in y direction, and dz, that is in z direction. The intensity of the pressure in x direction is px and intensity of the pressure in y direction is py, and the normal pressure which is acting on this inclined plane, that is equal to ps. So this inclined plane makes an angle theta with respect to horizontal. So if you are considering the equilibrium of this fluid element, then we have to consider the algebraic sum of the forces acting in x direction equal to 0, algebraic sum of the forces in y direction equal to 0, and algebraic sum of the forces in z direction equal to 0. Now the force acting on this element equal to this px into this area, because this is a normal area. The pressure force which is acting in y direction equal to py into multiplied with this area. Similarly, if you are considering the pressure force here on this plane, that is equal to ps into the normal area. In order to maintain the equilibrium of this fluid element within the fluid under rest condition, then we have to see sigma fx equal to 0 and sigma fy equal to 0. Now let us consider the forces in x direction. Px is the intensity of the pressure in x direction. So the pressure force due to Px can be calculated as Px multiplied with this area, that is ABEF. That means force due to Px equal to Px into area ABEF. So area ABEF means it is dz into dy. So it is acting in this direction. Other force which is acting in the horizontal direction is force component of Ps, horizontal component of force due to Ps, that is acting opposite to the direction of Px. So if you are considering the component of this force Ps in x direction, that is equal to Ps into area ABCD into, because we are considering the horizontal component, so it is multiplied with the sine theta, where theta is the angle made by this plane with respect to the horizontal. So sine theta equal to dy by ds. So if we are substituting here, it is equal to negative ps multiplied with ds into dz, that is the area of ABCD, into sine theta is dy by dl. So if you are simplifying, you are getting it is negative ps into dy dz. So if you are considering sigma fx equal to 0, then we have to add these two terms to balance this equation. Then you will get as px into dy dz minus ps into dy dz equal to 0, or px equal to ps. Now let us consider the algebraic sum of the forces in y direction. The force due to py equal to py multiplied with this area. So thus can be calculated as py into, this is dx and this is dz. So it is py into dx into dz. Now vertical component of force due to ps, it is acting in vertically downward. So the component of this force in vertical direction equal to, again we are putting a negative sign because force component of ps in vertical direction, that is vertically downward, that is opposite to the direction of py. So that is why we are putting a negative sign here also. Its value equal to minus ps into area ABCD into cos theta. So cos theta equal to dx divided by ds. So if you are substituting this expression is simplified into minus ps into dx into dz. So if you are satisfying this equation, that is sigma fy equal to 0, that means we have to consider all the vertical forces. We considered the vertical force due to py. We also considered the vertical component of force due to ps. The remaining force is the weight of this element. So this is the fluid element in the form of a triangular prism, and the size of the element dx, dy, dz, which defined is very small in such a way that we can just neglect the weight component. That is why we are not accounting the weight component. So if you are substituting these two, then you will get as py into dx dz minus ps into dx dz, or in other words py equal to ps. If you are considering sigma fx equal to 0, px equal to ps. Similarly, if you are considering sigma fy equal to 0, we got py equal to ps. So that means px equal to ps, which is equal to py. So hence the proof. What is the proof? Pascal's law states that intensity of the pressure at any point in the fluid at rest is equal in all directions. Now let us discuss about transmissibility of liquid pressure. So if you are applying certain pressure to a point in an incompressible liquid under rest, which is enclosed in a closed container and it is under equilibrium condition, it is transmitted to all other parts of this container without any change. So that is called transmissibility of liquid pressure. So this principle has many applications in engineering field. To elaborate this, we can consider an example. Let us consider a closed system which is fitted with 4 pistons. So these 4 pistons have different area openings, and these openings are tightly fitted with this piston. So A, B, C, D are the 4 pistons, and the corresponding area is indicated by lowercase letters A, B, C, D. All these openings are of different area. Initially, the system is under equilibrium condition. Suppose we apply a pressure P at the point A. So because of this principle, the same pressure is transmitted to all other points without any change. Hence, the equilibrium condition of the system will be changed. If we wanted to bring the fluid body to previous equilibrium condition, we need to apply the corresponding forces at each of these points. That means a force of P into B we have to apply at the point B, and a force of P into C we have to apply at the point C, and a force of P into D we have to apply at the point D, so that the system comes back to original equilibrium. So this principle, transmissibility of liquid pressure, has many applications, and one of the application is Bramah's press or hydraulic press. So which consists of 2 cylinders which are connected by a small tube. So these 2 cylinders, one is of smaller size and other is of larger size, and these 2 are fitted with pistons. Now these 2 cylinders are connected by the tube and it is filled with liquid. So normally we are using oil. So based on the principle of transmissibility, if you are applying a pressure at any point in an incompressible fluid under rest and it is enclosed in a container, is transmitted without any change. So if you are applying a pressure here, so applying pressure here is P by A1. So the same pressure is available here also. If you are applying a force P here, then so that can be balanced by a large weight here. Here the cross section area is large. So if you are applying a force P here, then the pressure developed here is P by A1, and correspondingly we can lift a weight W here, where capital W by A2 is as same as that of P by A1. So based on the transmissibility of pressure, so we can write here intensity of pressure P equal to P by A1, that is equal to capital W by A2, or we can write W by P equal to A2 by A1. So this principle we can use to compress bales of cotton. This is also used in lifting mechanism called the hydraulic jack. So that means by applying a small force, we are able to lift a large weight here. So this can be explained by considering a small example. So here the diameter of the ram and plunger of the hydraulic press are given. So this diameter is 250 mm and this is equal to 40 mm. And find the load that can be lifted when a force of 450 Newton is applied at the plunger. So here P value is given to you as 450 Newton. What you can do, you can utilize this equation and you can determine the value of capital W, that is weight that can be lifted. Consider the representation of absolute and gauge pressure. A huge layer of atmosphere is surrounding the earth. So the pressure exerted by the atmosphere on Earth's surface, that is called atmospheric pressure. Above the mean sea level, atmospheric pressure is approximately equal to 101 0.3 kilopascal. There are two systems is available for the measurement of pressure. One is absolute system, so that is called absolute zero or complete vacuum, and other is local atmosphere, or we can call as zero gauge pressure. We can use these two reference levels for the measurement of the pressure. So if we are measuring the pressure above this absolute zero, we are referring that as absolute pressure. But if we are measuring the pressure based on atmosphere pressure as datum, we are calling that is gauge pressure. All absolute pressure are positive, whereas gauge pressure can be positive or negative. So gauge pressure will be positive if the measuring pressure is above atmosphere pressure, and the gauge pressure will be negative if we are measuring the pressure below atmosphere. So local atmosphere pressure equal to approximately 101.3 kilopascal. Let us consider a point A. So the absolute pressure at the point A is the one which measured by considering this level as the datum, whereas gauge pressure at the point A, where we are referring this value as the datum. Similarly, if you are going to measure the pressure at a point, that is here, so here also we can represent the pressure at the point B as absolute value by considering absolute zero as datum. Similarly, it can also represent as gauge pressure if you are measuring this value from atmosphere pressure. So this point is below the atmosphere pressure, so it is referred as vacuum pressure or negative gauge pressure at point B. So we can establish a relationship between the absolute pressure and atmosphere pressure as P absolute equal to P atmosphere plus P gauge. Remember, P absolute is always positive, whereas P gauge can be positive or negative, depends upon whether we are measuring the pressure above atmospheric pressure or below the atmospheric pressures. So let us explain this with an example. Here, a vacuum gauge connected to a chamber reads 40 kilopascal at a location where atmospheric pressure is 100 kilopascal. Determine absolute pressure in the chamber. So here P absolute to be determined. So P atmosphere is given as 100 kilopascal and gauge pressure is given as 40 kilopascal, but it is given that vacuum gauge is used. So that means this 40 kilopascal is negative. So P absolute equal to 100, that is the P atmosphere, 100 kilopascal minus 40 kilopascal. So that means P absolute value, that is equal to 60 kilopascal. Now we come to the end of the session. All other discussions are coming in the incoming series. For the time being, it is enough. Thank you. Await your comments.